So since volumes have three dimensions, okay, so it's going to have three dimensions. We measure volume with the number of cubes. So when we count the cubes, we are able to calculate volume. So again, we have a cylinder here. We want to find the surface area and volume. So I'm going to do the surface area first. The surface area is harder than volume because it involves more calculations. Okay, so there's my surface area, my net. It's going to be 12 high. The width of this is going to be pi times diameter, so 14 pi. Since the radius here is 7, we're going to square the radius, and we're going to get 49 times pi as, as the area of the circle. And when we work out the area of the side surface here, we have 12 times 14. That's going to give us a 168 pi. Okay, so to again work out the surface area, we can keep this in terms of pi. So the surface area is equal to 49 plus 49, that's 98. So 98 pi plus 168 gives us 266 pi centimeters squared. Again, make sure the units are correct. So centimeters squared. When you have to write the units to indicate that that is area. So 266 times pi. The decimal value of this is approximately 835.66 centimeters squared. Working out the volume. The volume is a little bit easier. Again, it's the area of the base times the height of 12. The area of the base we calculated as 49 pi. So the total volume is 49 pi centimeters squared times 12 centimeters gives us 588 pi centimeters cubed. Okay, so again, now that we take the area and give it some thickness, we get cubes. So when we approximate the decimal for this, we're looking at about 1,847.26 centimeters cubed. And again, if you're somewhere close to that, that's good enough because we might have some error from rounding. So this cylinder here has a hole, and we're going to draw the net. Now this one we technically can't draw the net because we have a side surface. That's the outside surface, and I can attach my cylinder with a hole. Okay, so that's the top, that's the bottom. But there's also an inside surface that we have to account for, so we can't forget about this inside surface. Okay, so I'm just going to draw another rectangle, and we can't draw the net just because we can't attach it, but we can draw all the surfaces. So we're going to calculate the area of the rectangular surfaces first. So the outside diameter is going to be 80, so the radius is 40, so outside is 80. So this length here is going to be 80 pi. Since the thickness is 12, we multiply that, we're going to end up with 960 pi centimeters squared as that side surface. We'll do the same thing for the smaller rectangle here. That's the inside. Okay, so that's going to be, the inside radius is 25, so it's going to be 50 pi. 2 times the radius times pi gives us the inside circumference. The height is 12. Okay, the height is 12 in both cases for both rectangles here. That inside surface works out to be 600 pi centimeters squared. So we're just left with the top circle and the bottom circle, so we want this surface in here. Okay, so that surface, some room to write the surface in, is going to be the difference. Okay, so the circles, so the circle area is going to be the outside circle, so square the radius and times it by pi, and we're going to subtract the inside circle. So we're going to square the radius and times it by pi. So 40 squared minus 25 squared is going to give us 975 pi, and that's going to be centimeters squared. Okay, so that's going to be 975 pi centimeters squared. So we have two of them. Okay, so now we've, if we look at our net, we've accounted for all the surfaces. So I'm going to calculate the total surface area. So the surface area is going to be composed of our big rectangle. It's going to be composed of our little rectangle. And it's going to be composed of two circles, or two kind of donut circles. So 2 times 975 pi. So when we sum that all up, okay, and again the key is really to keep track, to keep this organized. I end up with 3,510 pi, and that's going to be centimeters squared. And we can give the decimal approximation for that. So 11026.99. Okay, so if you're somewhere around 11,000 centimeters squared for the surface area, that is going to be good. You've done the right calculations. Again, we're going to be off, we may be off a little bit by some rounding that we may have introduced. Now in terms of the volume, okay, so the volume, we're going to do the area of the base times the height. Now we don't have to, we could find this big cylinder and subtract a little cylinder if we like, but we already have the area of the base. Okay, the area of the base, this base here, that has slices that are the same all the way through that 12 centimeters. So we can use that, the area of the base, and multiply it by the thickness of 12, and that will give us the number of cubes involved in here, because this is going to measure squares in here, and then we multiply squares by thickness, and that gives us cubes. So this is going to be the surface area of that surface is 975 centimeters squared times 12 centimeters of thickness, and that gives us a volume of, so 975 times 12, it's going to give us 11,700 centimeters, or pi centimeters squared. Sorry, I forgot to put the pi into this here. Okay, so 975 pi centimeters squared, and this is going to give us centimeters cubed. Okay, so times that by pi, and we end up with approximately 36,756.63 centimeters cubed. And again, if you're somewhere around 37,000, depending on the rounding involved, you can assume that you've done the right calculation. So here's my two solutions here.